Howdy there, Internet students. It's Mr. Hermanson again. Today it is time to learn how to recognize direct variation. I know we've talked a little bit about that, but today we're going to make it so that you for sure will know how to recognize it. All right. So, and there's three ways you're going to have to be able to do that: from its equation, from a table of values, and from a description in words. To help you get started on that, we're going to do some descriptions, and then we will create the table of values and the equation and decide whether or not we think it's a direct variation. Okay, so on the next page we have the first problem. At the beginning of the school year, Eli had nothing in the bank. Then he started a part-time job and deposited $25 a week. So first of all, let's create a table to represent that. Let's just do, our independent variable is the weeks. So let's put W there for weeks. If you want to just put X there, that's a letter we always use for independent variable. That'd be fine. And then the other variable is how much money he has in the bank. So let's use T for the total amount of money in the bank. Usually we're going to start at 0 and then we'll go up from there. At 0 weeks, since he started with nothing, he will have $0. At 1 week, he will have 25. At 2 weeks, he'll have $50, 75, and 100 after 4 weeks. Now, the questions we were asked is, first of all, we have to decide whether it's a direct variation, linear but not a direct variation, or nonlinear. Now, the way we tell if it's linear is, are the numbers going up by the same amount every time? And they are. We're always adding 25, so it's linear, we know that. And then to tell if it's a direct variation, if it's linear and it starts at 0, 0, it is a direct variation. The other way you can tell is ignoring the 0, 0, are the ratios of the dependent variable over the independent variable always the same? In other words, is 25 over 1 equal to 50 over 2 equal to 75 over 3? And yeah, those would all simplify to 25 over 1. So it's definitely a direct variation. So here's our abbreviation we'll use for that, DV, direct variation. Okay. Now that we know it's a direct variation, we want to write an equation for that. And direct variation equations are really simple. It's just y equals some number times x. So we have to figure out what that number is. And the number is the rate. And in this case, the rate is $25 a week. So we can just write y equals 25x, or using the letters that make sense for this problem, T equals 25 times the number of weeks. And then the other thing you have to do is explain how you know it's a direct variation. And I'm just going to say it's proportional. You could also say that you know it's direct variation because it starts at 0, 0. And it goes, and it's linear. All right, so let's try another problem, and then I'll let you try some. So at the beginning of her vacation, Tanya had 150 in the bank. Each week she deposited another $25. So she's depositing $25 just like Eli. Okay, we'll make her table in red here so we don't mix them up. So again, we have weeks and we have the total money in the bank. We'll do the first few weeks. Now Tanya started with 150, so that means at 0 weeks she's already got 150. And then she's putting in 25 each week. and so on. Okay, and so first of all, we already know it's not a direct variation. Even though it's linear, it doesn't start at 0, 0. The numbers would not be proportional. 171, 5 over 1 is not equal to 200 over 2. It's not equal to 225 over 3. You can see that. So you're going to say it is linear but not a direct variation. And I'll put a slash through it to show not direct variation. My explanation, you already heard that. It's the reason we know it's not a direct variation is it doesn't start at 0, 0. I'm going to just say not proportional. And it is linear though, so we can write an equation. Now linear equations that are not direct variations can be written like this: something times x plus something extra. That extra is the beginning amount. So we're going to write T equals, it's going up by $25 per week, so 25 times W plus the starting amount, which is 150. All right, I'm going to let you look at 3 and 4 and decide, and then I'll write my answers in and you can check back and see if you agree with me. All right, here's what I got. Number 3 was kind of tricky. How do you do 1/5 of your remaining amount? And the way you do it is divide it into 5 parts and take away one of those parts. But since the numbers are changing, the amount you take out is changing. So that one's nonlinear. Numbers are not changing by a constant amount. And so don't even worry about writing the equation. We don't know how to do that yet. Number 4, you should have noticed that it's linear. It doesn't start at 0, 0 though, so it's not a direct variation. It's not proportional. And the equation has a negative in it because you're withdrawing. I hope you guys realize that withdrawing is taking away. All right, let's move on to the next page. Now, in this one, you have to decide whether the graph is a direct variation, linear, or not a direct variation, or nonlinear. Okay. Now, linear graphs are straight lines. So we know that. So if it's a straight line, you know it's linear. And if it starts at the origin, then it's a direct variation. And the way you see that it starts at 0, 0 is it's starting right in the corner where the x and the y-axis come together, like number 6 is a direct variation. And number 5, it is linear, but so we're going to say linear because it's a straight line, but it's not a direct variation. So go ahead and do the rest of those, thinking about that. See if you get them right. All right, so here you go on those. Number 7, of course, is nonlinear because it's curving. Number 8 is linear. It's a straight line, but it does not start at the origin, so it's not a direct variation. And you can see those other answers. The next thing we're going to do is try to tell whether it's linear or not by the table. Now, if it started at 0, 0 and the numbers went up by the same amount, you could say it's a direct variation, but we don't see the 0 in them. So we're going to have to do the proportional thing. So here's what you're going to do. You're going to check y divided by x, which in this first one would be 3 over 1, 7 over 2, 11 over 3, 15 over 4. And what you want to see is, are those all the same numbers? If they are, if they all simplify to the same thing, the 3 over 1, then it's a direct variation. As long as the numbers are going up by the same amount. Now these are, because these are all going up by 1 and these are all going up by 4. So in this first one, dividing those you get 3, dividing those you get 3.5, dividing these you get 3.6 repeating, and on this one you get 3.75. Obviously those aren't the same numbers, so you're going to say no. It is linear though, because the numbers are going up by the same. It's not a direct variation though, because we can see that they're not proportional. The ratios do not equal each other. So why don't you work on the other three, see what you think. All right, here's what I got. This one here is nonlinear. We can tell because even though U is going up by 1 every time, W is increasing by different numbers. It's +2 there, then +6, then anyway, so that's nonlinear. Number 21 here is linear, and we can tell that because these are going up by 2 every time. These are going up by 20 every time. So that's true, but it's not a direct variation because if you look at the ratios, like 26 divided by 2, that's equal to 13. That is not equal to 46 divided by 4, which is like 11.5. So you'll see those ratios are not equal. And this last one is a direct variation, and you can tell by the ratio. 6 divided by 2 is 3. 18 divided by 6 is 3. 27 divided by 9 is 3. So the equation, a simple direct variation equation, is you can multiply 3 times t to get r. All right. We're done with the lesson here. If you want to fill this in to help you have a little bit of a study chart for direct variations, you can go ahead and do that. Otherwise, you can get started on your practice. When you do this first 1-1b practice, these are Roman numerals. When you answer the questions, I just wrote them as 1, 2, 3, 4, and 5. So if you want to keep that in mind when you're doing that problem. So this is table 1, table 2, table 3, table 4, table 5. And this is graph 1, graph 2, graph 3, graph 4, graph 5. All right, well, good luck with that, and we'll talk to you soon.